Welcome once again to Symbolic Logic. I'm Mark Story. We're at Bellevue College. This video is going to give you a presentation of what indirect proof looks like. Imagine you've got an argument. You know what the premises are. You know what the conclusion is. Look at the conclusion. If it's conditional, you'll use conditional proof. That's a different technique. If it's not a conditional, like it's P or tilde P or P dot O, we'll want to use indirect proof. This is usually the easiest way to get the problem done. It'll usually keep the problem shorter, make it easier. It's your advantage to do this. So let's see how it looks. Let's do a real simple problem just to see how indirect proof will actually look. Here's an argument with one premise. By convention, we have the slash, and there's the conclusion, tilde A. Now, if I could use direct proof and just use the rules I have, I would. But I've got indirect proof as an option. So I look at the conclusion. Is it a conditional? No. So I won't use conditional proof, I'll use indirect proof. And the way indirect proof works is you assume the opposite of your goal. Now the opposite just means if it's negated, unnegated. So I'm going to assume the opposite, which would be A. I indent to the right. A, there's the opposite of my conclusion. And I write AIP, assumption indirect proof. I don't know that's true. In fact, I actually think it's false. I believe if the premise is true, I should get tilde A. So I'm assuming something I think is crazy, nuts. And the idea behind indirect proof is we assume something that's crazy and we go until we get a contradiction, something of the form R and not R. R is true and R is false. Well, we know that's crazy too. So if this gives me this contradiction, I know this is false. I conclude, therefore, this must be false, and I get the conclusion. Let's see how it looks. So what I'm going to do is I'm now looking for a contradiction. A and not A, P and not P, Q and not Q, B and not B, anything that comes up. Well, I see that I can do, for instance, an addition. Notice I'm inside this indented sequence. I'm going to add a B to line 2 using our addition rule, which we learned quite a while ago. Why did I do that? Because now I want to do a modus ponens, and that'll give me tilde A with 1, 3, modus ponens. I was looking for a contradiction. Well, here's one right here, A and not A. So what I do, and this is usually how it happens, you can join two things. I can join them. To get an actual contradiction, something of the form R and not R. Well, we know these are false. If we did a truth table, we'd have nothing but F's under here. We know these are false. So what we've done is we said, if this is true, this must be. But we know this is false. Therefore, we get to say that must be false also. So I pull out one column to the left, and I write the opposite of my assumption. And that's going to be from lines 2 through 5, indirect proof. And we'll draw a vertical line here. That vertical line locks off that indented sequence from any further use. If the proof needed to continue on, I could use lines 1 and 6, but 1, 2, 3, 4, 5 are locked off because I don't know that any of that stuff's true. It's all based on this crazy assumption. The only thing indirect proof gives me, lets me say, is that assumption must be false. And if I assume the opposite of my goal, I'll end up getting a contradiction, which lets me say that assumption must be bad, which is what I say here. And since I assume the opposite of my goal, I end up with actually what I'm looking for, tilde A. So take a look at your conclusion. If it's not a conditional, assume the opposite of the whole thing, and then you'll find a contradiction and you'll be able to get the conclusion you're looking for. Let's see one more thing here. Let's look at the picky things. That's a dash, not a comma. You're not appealing to lines 2 and 5, you're appealing to the entire sequence. This is IP, indirect proof. This should be AIP, assumption indirect proof. You write, say that up here. You indent every time you make an assumption, and you unindent every time you do an IP move. And don't forget to draw the line.